Welcome to True Projects. In this video, we are going to explain about project title, a hybrid metaheuristic method in training artificial neural network for bankruptcy prediction. The project focuses on the significance of bankruptcy prediction in the financial analysis and its adverse consequences for different stakeholders, including the business owners, managers, shareholders, employees, manufacturers, suppliers, customers, and the government. It highlights the extensive research conducted in recent years on predicting the primarily using conventional statistical methods. Additionally, the project acknowledges the prediction encompasses multiple disciplines such as finance, accounting, business management, and computer science. The objective of this project is to offer users a complete workflow to analyze the bankruptcy prediction utilizing a dataset. The workflow comprises the module such as dataset upload, pre-processing, executing the PSO algorithm, training an ANN with all the features, training an ANN with PSO selected features, and visualizing the comparison of prediction accuracies. The primary goal is to enhance the accuracy by utilizing the PSO algorithm to identify the features in the bankruptcy prediction process. These are the basic requirements that are needed to implement this project. Operating system as Windows, processor of i5 and above, RAM of 4 GB and above, hard disk of 20 GB and above. Software requirement, Python IDE with version of 3.7. These are the modules that are developed to implement this project. Upload the bankruptcy dataset. In this module, the application uploads the dataset. The dataset contains the information about different companies, specifically labeling them as either bankrupt or non-bankrupt. After uploading the dataset, the module plots a graph to visualize the distribution of bankrupt and non-bankrupt companies. The second module is pre-processed dataset. This module involves pre-processing the dataset before training the models. It reads the dataset and performs the necessary pre-processing steps such as handling the missing values. The module shuffles the dataset to ensure the randomness and then split it into training and testing subset. The third module is run PSO algorithm. The processed feature form the dataset or input into the particle swarm optimization algorithm. The PSO algorithm aims to identify and remove the irrelevant features, selecting the most important features that yield the best accuracy for the bankruptcy prediction task. And the fourth module is train ANN on all features. In this module, an artificial neural network is trained using all the features from the dataset. The ANN model is trained using the training data, and then the trained model is applied to the test data to calculate the prediction accuracy for bankruptcy classification. And the fifth module is train ANN on PSO features. This module involved training another ANN model, but this time using the features selected by the PSO algorithm. Only the relevant features identified by the PSO are used to train the ANN. Similarly, the trained model is applied to the test data to calculate the prediction accuracy. And the final module is comparison graph. The module generates a graph to compare the prediction accuracy obtained from the two ANN algorithms. It visualizes the performance difference between using all the features and using the features selected by the PSO algorithm. These modules collectively form a workflow for analyzing the bankruptcy prediction using the uploaded dataset. The comparison graph provides insight into the effectiveness of feature selection using the PSO algorithm and improving prediction accuracy. The execution of the project. To execute the project, first we need to open the code folder. This is the code folder consisting of different files. The dataset folder consisting of an data named bankrupt in the XLS worksheet, in the form of XLS worksheet, and the model folder. Here in this folder, we will have H5 files which contain the deep learning algorithms information. These .h5 file can be loaded into project code during the runtime to utilize the trained model for various tasks such as making predictions on new data or performing the specific operations. And the bankrupt prediction and the output or the HTML files which is used for the comparison graph output, and the bank prediction and bank prediction IPYNB as the code files for the implementation of the project, and this is an BAT file. This is run.bat file. Instead of executing the program in command line interface, we created the Windows BAT file to execute the project. Now to run the project, double click on run.bat file. Here, this is the graphical user interface. With this, we are interacting with the program. And click on Upload Bankruptcy dataset. Using this button, we are going to import the dataset from the folder. Here, select the Bankrupt XLS worksheet and click on Open button. Here, the dataset is loaded. In this screen, we get an graph. Here, x-axis represents the type and the y-axis represents the count. And now this close the graph. And click on Pre-process dataset button to remove the missing values, and then split the dataset into the training and testing part. Here, the data is split into training by 80%, that is 10,558, and for testing 2,640. And click on Run PSO Algorithm button. By selecting the relevant features and removing out the irrelevant features. In this screen, we can see that after applying the PSO algorithm on the dataset contains the 94 features and it is reduced to the 57. Now click on Train ANN on All Features button. To train ANN on all features, and by getting this screen, here it gives an accuracy matrix where x-axis represents the predicted class and y-axis represents the true class. In this graph, ANN predicted the 1167 and 659 records correctly, and 711 and 103 records as incorrect. And now close this graph. Now click on Train ANN on PSO Features Algorithm button. Here, in this, we get an confusion matrix. Here, x-axis represents the epochs, y represents the accuracy, and the top here of y-axis represents the true class. Here, the 1 and 1 represents the negative, and the 1069 and 13,069 represents the true rate. And now close this graph. Here the ANN gives the accuracy of 99.9 with the precision of 99.9, recall of 99.9, and click on Comparison Graph button. Here this gives an accuracy of ANN with all features and ANN with PSO related selected features of accuracy, precision, recall, and F-score. In conclusion, the project successfully developed a workflow for bankruptcy prediction using a dataset. By employing the PSO algorithm, the model identified the relevant features and improved the prediction accuracy. The comparison graph highlighted the effectiveness of feature selection in enhancing the performance of artificial neural network model. The project's results demonstrate the potential for accurate prediction and provide the valuable insight for financial analysis and decision making.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.